Hey guys, welcome to problem 4 of competition 1. Determine the sum. And we're given a long string of numbers which we obviously do not want to compute by hand. But in problems like these, it's important to see if you can find a pattern. So I see a pattern here. We have a positive number, a negative, a negative, a negative. So it's going to be one positive followed by three negatives. At least let's see if this holds. One positive, three negatives, one positive, three negatives, and then we have another positive here. So looking at this pattern, well, I'm gonna focus on one of these quote unquote boxes at a time and see what they give me. So for example, here, 1 minus 2 minus 3 minus 4, well, that's gonna give me negative 8. What about this second box right here? This is gonna give me negative 16. And finally, this box is going to give me, if you sum up everything there and subtract, you will get negative 24. So there seems to be a pattern here where each box is smaller than the previous one by 8. So this is going to help us compute the sum of the total, just of the expression. So if each box has 4 numbers, how many boxes do we have? Well, if there are a total of 2,020 numbers, and each box has 4 numbers, well, that's going to give us 505 of these boxes or repetitions of this pattern between one positive number and 3 negative numbers. So now we're going to try to express this pattern with summation notation. So I'm going to write it out first and explain it. So what I just did here is, with this single line, I wrote out this entire thing here at the top. And let me explain what this does. So first, I'm going to plug in the first value of n, which is 1. So it's going to be negative 8 times 1, which is obviously going to be negative 8. Now my n is going to go from 1 to 2. So what happens when I plug in n when n equals 2? Well, I would get negative 8 times 2. Well, now n is going to go to 3. It's going to bump up by 1 each time. So I'm going to get negative 8 to the 3. And so long until my last n, which is my upper bound n, which I wrote to be 505, I would get this. And if you look into each of these, if you figure out the expression for each of these, you would see, well, I'm basically just modeling where I'm going down by 8 between each time until I finally reach this final one, which is exactly what's going on here. All right, so now that I've modeled the above expression in sum notation, I'm going to solve it. What I'm going to do is I'm going to take out the negative 8 because negative 8 is a constant. So I'm going to rewrite it as negative 8 of this of n. And again, I'm going to do something where I'm going to write the solution and then I'm going to explain it, so stay with me. This entire thing would be equal to negative 8 times 506 over 2 times 505. So how did I get there? Well, there is a formula, which I will explain. If you have something like this, I'll just put a random number like 10. This is equal to, the sum of this is equal to n times n plus 1 over 2. So this is basically what I did over here. In this case, the uppermost bound is 505. Well, first I factored out the negative 8. Then I did 505, which is n, plus 1, 506, over 2, times 505. And now, again, this doesn't maybe make conceptual sense, but I'll try to offer a visual geometric proof for why this is equivalent to this, where these n's would be replaced with 10s, because 10 is the upper bound. I'm going to choose an even simpler one, where you start with n equals 1, and you go up to n equals 4, and you just have n here. Well, what would this be equal to? This would be equal to 1 plus 2 plus 3 plus 4. And let's draw this geometrically. I have one box. Let's assume this is a 1 by 1 box, plus a 2 by 2, plus a 2 1 by 1 boxes, plus 3, plus 4. So how could you calculate the area of this shape? Well, let's draw a line like this so that we create a triangle. This is the triangle I'm talking about. Well, the base of this triangle is going to be 4, obviously, and the height's going to be 4. So what's going to be the area of this triangle? It's going to be 16 over 2. Or let's say I didn't necessarily have 4 here, but I had a variable n. It would be equal to n squared over 2. But let's not forget about this part. What this would basically be is, well, you have n, 4 of these half squares, so it'd be 4 over 2. Or, again, if I had a variable number, it would be n over 2. So the total area would be n over 2 plus what we got from the triangle, n squared over 2, which is equal to n plus n squared over 2. And now I can factor out the n to get n is equal to n plus 1 over 2. So I just offered a geometric or visual proof for why, if you just have a variable raised to the first power under this summation notation, it is equal to n times n plus 1 over 2, which is exactly what I did over here to get from this ugly expression to something that we can calculate. And you're going to have to take my word for it here, but this ugly expression is equal to negative 1,022,120. So this would be your answer. In my opinion, this was more of a complex problem, as it requires to have some skills that maybe you just simply haven't learned yet, like dealing with summation notation and just knowing that and knowing this formula above. But I hope by demonstrating why it works conceptually, it'll maybe stick with you a little bit longer. And this is how we were able to find the sum of this ugly series as one number. Thank you.